Okay, so we're ready to go on talk about the urinary system. Obviously, very important. What does it do? Eliminates organic waste, regulates the amount of sodium, potassium, and calcium and magnesium uh, that are in your plasma, helps regulate blood volume and blood pressure, uh, it adjusts water loss, regulates pH, it conserves nutrients. So the urinary system is made up of the kidneys and very, very important organ. We have a blood volume of about 5 to 6 liters. 180 liters of blood goes through the kidney every day. So it's a very active and important organ. So what are the components of the urinary system? Kidneys. Ureters lead from the kidneys to the urinary bladder. The urinary bladder eliminates urination in the urethra. Men have a much longer urethra. Women have a much shorter urethra, which apparently makes it easier for urethral infections to take place, urinary tract infection, UTIs. So everybody knows you have to keep this whole system pretty clean. So if we look at a pictorial representation, so here we have the kidneys, the ureter, the bladder, and the urethra. Kidneys are retroperitoneal. They're behind the body cavity lining of the lower thorax, the abdominal cavity. They're surrounded by capsules, and the renal artery and renal nerve enter at the hilum. I'll show you what the hilum is and where the artery goes in and where the renal veins. So the nerves and the blood vessels enter at this hilum point. So you can see the hilum is right here, this little indentation. And you can see that the kidneys are behind the body cavity, and it's around the 11th and 12th ribs and close to the first lumbar vertebrae. Okay, so uh, here's the hilum where the renal artery and renal vein go in, and the uh, ureter, the bladder, and the urethra. If you do a cross section of the body, you can see that the kidneys right here are behind the body cavity. This is the membrane that contains the stomach, and on a more superior position will contain the heart and the lungs. But this lining here keeps the uh, spleen and the stomach and so on totally separate from the retroperitoneal. So this is the peritoneum, and the kidney is retroperitoneal behind this membrane. When you are a boxer or you hit your lower back, you can often damage your kidneys and cause bleeding in your urine. Hopefully, most of the times that will heal, or you may have to have surgery if it's very, very bad. Okay, so let's look at the internal anatomy of the kidney. Nephrons are the basic functional unit. We'll talk about the pelvis and the minor and major calyxes. Okay, so the outer layer of the kidneys is called the cortex. The medulla is next. Here's the hilum, right? The hilum is where the uh, ureter comes out, and the renal pelvis is where urine accumulates. So you have these renal pyramids that where all of the uh, nephrons are located. We'll talk more about the nephron. And so blood is filtered and waste are taken out and so on. And that's just the basic process. So when these renal pyramids open to a small opening into the renal pelvis, that's a minor calyx. And a major calyx is when multiple minor calyxes fuse together, and eventually they fuse to form the renal pelvis, and urine is dumped from the renal pyramids into the uh, renal pelvis and leaves through the ureter. So remember, there's cortex, there's a medulla, and we'll talk more about what is in the cortex. This is an actual kidney, and you can see that the major parts we talked about. Okay, is that somebody trying to get in, or is that? Nope. Okay. Okay, so this is an actual kidney which has been cut down to the sagittal axis. So in the cortex and somewhat in the medulla, this is the basic functional unit of the kidney. It's called the nephron. The nephron is connected to the blood vessels. Blood vessels allow the blood to be filtered, and all of these tubes have varying functions, and to the point where urine is processed and it leaves the collecting duct, goes into the minor calyxes, the major calyxes into the renal pelvis, and that ends up in the ureter. So the kidney blood supply, all I want you to know is that we have a renal artery and a renal vein, and then the blood then leaves the renal artery, and you have to have blood surrounding the nephrons, and we'll talk about that particular arrangement. Okay, let's go back here. Okay, so into each little nephron, there's a capsule, and since the blood, 180 liters of blood goes through the kidney every day, every little filtering unit is connected to blood vessels. Most of the blood vessels are in the cortex. You have some nephrons that dip down into the medulla. Other nephrons do not dip into the medulla. Remember, a nephron contains the glomerulus or nephron capsule, the proximal convoluted tubule, the distal convoluted tubule, and the collecting duct. Okay, so here's our basic nephron. So the slight gray is all of the nephron. Notice that blood has to come into each little capsule, and that capsule is called a glomerulus. And so blood comes in through the afferent arteriole and leaves through the afferent arteriole, and then the blood vessels surround all parts of the kidney, because as the blood processes the filtrate, you have to have some substances reabsorbed and other substances secreted and allowed to end up in the collecting duct and to be eliminated in the urine. This is a cortical nephron in the cortex. Okay, so this nephron is in the dips down into the medulla, but notice again there is the nephron made up of the glomerulus, the proximal convoluted tubule, the loop of Henle, the distal convoluted tubule, and notice all these tubes are surrounded by blood vessels, because some substances are reabsorbed into the blood, some substances are secreted into the tubules. So this is a very, very fine-tuned filtration system, recovery system, and getting rid of certain waste that have to go into the urine. So let's look at the urine here. Okay, so let's talk a lot about this right here. So here we have the afferent arteriole, where blood enters the each little renal capsule. The tuft of blood vessels in the renal capsule or renal corpuscle is called the glomerulus. So blood moves in, and then it leaves each glomerulus in the efferent arteriole. So notice there's all of these processes. The filtrate moves from the glomerulus into the proximal convoluted tubule. And here we have the movement of water, the movement of solutes. So in the proximal convoluted tubule, water is reabsorbed along with solutes such as sodium and potassium and glucose. And so what the kidney does, it dumps anything that goes through, leaves these blood vessels, but all you want to get rid of is the waste. So you have to reabsorb water, reabsorb ions, inorganic nutrients, so amino acids, glucose, sodium, potassium, and so on. So the filtrate continues to allow movement of the filtrate, and in the loop of Henle, we have much more absorption of water, and because the sodium and chloride, so further reabsorption of water and both sodium and chloride, but the primary reabsorption occurs here of sodium and chloride. So anything that the body has to keep, such as sodium, chloride, magnesium, calcium, the body has to keep a very exact amount to make sure homeostasis takes place. So your kidney is constantly adjusting your level of sodium, potassium, magnesium, calcium, bicarbonate, and everything. So, but here, secretion of ions, acids, drugs, and toxins. So you're going to have some water right here, variable rate. You're going to have reabsorption of solutes, but you're going to have a great loss of water in the collecting ducts. So you want to end up with urine that is gets rid of waste, may get rid of a little potassium and sodium and some other stuff. You don't want glucose here because then you'd have diabetes. Everybody knows that depending upon how much you drink, how much you exercise, the color of urine can be deep yellow or pale yellow. That indicates how much waste there's in the urine. But this is a finely tuned system that allows small molecules to be filtered out. Proteins stay in here in the blood. If you get protein in your urine, that's not a good idea. Okay, so again, the reabsorption of water and ions, further reabsorption of water, reabsorption of sodium chloride in the ascending limb, toxins secreted into the distal convoluted tubule, some more absorption of ions and organic compounds. So, and then you can have more water reabsorption here, and you can have both movement of ions in and out of the collecting duct. So the kidney is very, very important in sensing the amount of all of these substances, and also it'll help maintain blood pressure because the pressure of blood moving into the glomerulus in the renal corpuscle, it has to be maintained within a certain range. So that's the basic function of the kidneys. So they remove waste products, regulate blood volume, blood pressure, ion levels, and blood pH. Let's stop there and we'll keep going. So we're going to stop recording, stop recording, stop recording, stop recording.